Hello, everyone. Today we'll be presenting our final presentation, which is a health database. We gathered a lot of data on the WHO website, and we're excited to present it. This is a group project by me, Daniel Kalina, Karan, Chooks, Karan, and Sunny. So, our business space, I'll explain what it is and the significance behind this. So, the business space we're addressing is healthcare. We grabbed WHO data on all different sorts of infectious diseases, but our business space breaks down into two main categories. The first is clinical healthcare, which is where our data is seen as sort of business intelligence and by these companies that treat and manufacture treatments. So they're looking for to make a profit, look at what possibilities for research and development, as well as humanitarian assistance. But the other category is public healthcare and education, where our data is seen as a way to educate the public and inform individuals on how to make decisions with regards to public policy or research. And so our focus and typical users so our focus for this database was mainly on communicable diseases because these diseases have the highest impact since they can be easily spread through everyday activities and are less about changing our habits and more about containing and isolating and quarantining possible dangerous diseases. And because there's such a large amount of diseases, both communicable and non-communicable, we decided to break that in half and just focus on the communicable to save memory and space in our database. And so typical users of this database include health policymakers and influencers, doctors, disease researchers and epidemiologists, government and private healthcare entities. And so it's any people that are both directly and indirectly affected by the disease and or are just interested in the data. Another big reason that we focused on communicable diseases is that we need to focus on the transactions between people and the new cases because if something's very contagious, we need to know when a new case was reported and when this transaction happened. Right, so our business space will impact the decisions made by several people, and this data is a primary source of information used to make high impact and large scale decisions, as well as everyday decisions by individuals. So it reaches to the small scale, which are in the individuals, but to the large scale as well with the companies and research facilities. So our biggest takeaway are that our data will be used to influence how businesses operate and decide what they will research, what treatments they will develop, and where their money will be spent. Because if they see a disease has a higher possible market, they will try to make more of that treatment. It would also affect doctors and how they will approach their patients because they will be looking at the data for new treatment options, and individuals as well because they will plan around how influential how widespread the disease is and how they could affect them. So by reading all this data, we're really empowering people in terms of educating them about the disease and also businesses in empowering them to make better decisions and business decisions.
The first phase for making our ERD was the conceptual phase. During the conceptual phase, we had certain expectations. Part of these expectations were to establish a business space, brainstorm and note down all ideas, and create a blueprint of the ERD in accordance with the user needs. During the conceptual phase, we did go through some problems, and these problems included the fact that the tables did not follow a consistent pattern. We had a lot of unresolved many-to-many relationships, and we had unclear labeling of entities and primary key, foreign key relations. This is the first ERD that we created. It has many flaws, as you'll be able to tell. Some of them include the fact that we had a new case table. This new case table doesn't need to exist because in practice a new case would just be inserted as a new row in the case entity, not as a new entity entirely. We also removed the communicable entity because a disease type did not originally follow best practices of ID, name, and description pattern. So we added a disease type name as a foreign key, and thus communicable would be a value of disease type name instead of its own entity containing true, false, or yes, no values. These were some of the many errors we had during this first ERD. The second phase that we had to go through was a logical phase, and in order to normalize the ERD, we had to identify many of the mistakes we made in the conceptual design phase. Some of the mistakes that we made are highlighted in these bullet points. We removed a referential loop between region, country, and disease by removing the entity region disease. We did this because, by definition, a region defines a country. Thus, in practice, we can write a query to find which diseases each region has. As I mentioned before, we removed communicable. We added treatment ingredient, treatment manufacturer, and manufacturer tables, as this better reflected the many to many relationships without having to store ingredients or manufacturers multiple times in different places. We also removed the income group name as values from region and country. We created a new entity, income group, which has a one is to many relationship to country. This prevented redundant data in the values of this entity, and countries could belong to one income group. Our finished ERD is way more streamlined and more efficient. We made sure that there weren't any referential loops, as I mentioned earlier. We also made the ERD less redundant. For example, we attached the country table to the strain table via country strain. Since the strains of a disease are a more specific type of the disease, we can compute values of an entire disease by adding the values of all the strains of a disease. Another example was adding treatment ingredient, treatment manufacturer, and manufacturer tables. This better reflected the many to many relationships without having to store ingredients or manufacturers multiple times. Our final ERD also uses a lot less memory, as we managed to remove a large. This is our new and revised ERD. As you can tell, it looks a lot more streamlined. It has fewer errors and fewer entities as a whole, and it makes a lot more sense logically. Sunny will now give you a quick overview of our database and run you through some of our code and explain to you some of the stored procedures, business rules, and computed columns that we implemented with this database of ours.
So the first example here is a store procedure, which is to insert a new row into the disease table. This was for in order to do this, we started by declaring our variable names, which are disease type name, and disease description. And after going through the standard process of implementing a store procedure, I'm actually we're gonna insert a disease type of communicable, and a disease name of common cold, and the disease description is a contagious viral upper respiratory tract infection. So first, I'm going to run the store procedure function in order to ensure that it's free of errors, which it is, and then I'm going to run the execute function, and the messages that one row was affected. And in order to confirm this, we can select all from disease, which shows that if you look on row 3, and if you look at row 5 on disease ID 6, it's created a disease name of common cold, and it has a disease description there, and the disease type ID is 1 because type communicable was already declared before and already contains 2 different diseases. So our second example is of a business rule. The business rule was defined that was defined. The definition of the business rule was that treatments with more than 10 ingredients cannot be manufactured by the manufacturer Actavis. So in order to implement this, we actually have an alter function here because we've already created the table, and we cannot run a create function twice. So once I run this table, it shows that the commands were completed successfully. And in order to ensure this, we had to join multiple tables. So firstly, if you take a look back at our ERE, we went from ingredient to treatment manufacturer to manufacturer, and we can apply this business rule by running these lines of commands. And again we get a message that the commands were completed successfully. The third example here is of a computer column, and in this column we're adding all the treatments completed by a certain manufacturer. So again, in order to implement this, we will take a parameter into the function. So first, I'll run this function to ensure that the command is completed successfully, and then I will apply the computer column. Okay, then firstly, I'll show you the manufacturer table to show that firstly, I'll show you the manufacturer table to show you that there are only 3 columns right now, and then we're going to add a 4th column by applying this computer column. So if I run this command now this has created a total treatments a total treatments column which is added the which contains the of sum of the treatments for each manufacturer. So now we can actually see the change in the table once if I run this query again. Now it has a total treatments column, and each manufacturer has a total of 2 treatments. And our final example is a complex query. So the complex query is we the complex query we used was to find the name of the countries where there have been more than 10 cases of tuberculosis, where the strain was mycobacterium reported after 2005, and the treatment lasted more than 30 days, where the treatment type was antibiotic. Antibiotic ingredient used in treatment. The ingredient used in treatment was isoniazid, made by the manufacturer Shriji Pharma International. So again, on your screen is the actual query, including which includes a very complex subquery, and and if we run this, we actually get no results. Yeah, we actually get no results, and this is because our table was not populated enough to show results for such complex queries. Okay. So this is just a snapshot of our final database code. If you want to have a further look, if you want to have a deeper look into all the code that we created, you can have a look at our final database, and and yeah, uh, you can have a look at our final database. And thank you for listening.